All right, good morning. Thank you everyone for joining us for our Aim to Learn series. My name is Tom Reed. I work for Catalyst Connection and I support the AIM Higher Consortium. So just a minute, I'm going to talk about AIM Higher Consortium and then I'm going to turn it over to today's speaker. So if you're new to the AIM Higher program, that is a program that was funded by the Department of Defense, OLDC, Office of Local Defense Community Cooperation, to help to bring together and support small and medium-sized manufacturers in southwestern Pennsylvania and throughout the state of West Virginia to strengthen and expand within the DoD supply chain. There's a focus on the adoption of advanced manufacturing technologies. And so today, we do that in many ways, including education and through technical assistance. But today we're going to learn a little bit about smart and flexible building manufacturing through production digital twins. And I would like to present Dr. Pingbo Tang, Associate Professor of Civil and Environmental Engineering at Carnegie Mellon University. Welcome, Dr. Tang.
Thank you, Tom. Can you hear me okay?
Yes, perfectly.
Okay. Any background noise? Should I turn off the air condition?
I can only hear your voice. I don't hear any background noise.
Okay, that's great. Thank you, Tom. Hello, everyone. My name is Pingbo Tang. This is a research project we just started at Carnegie Mellon University, funded by Manufacturing Future Institute. Myself is the principal investigator. The two other researchers working on this project is Professor Bujua Kenji and Professor Yori Nakahira. We do have two industry partners who are working on the manufacturing lines of all kinds of building component or mechanical system component of buildings, which is DMI companies and modular. Then the title of the presentation is called Smart and Flexible Building Manufacturing Through Production Digital Twin. This is start with some discussion with industry about what is the benefit of a modular construction. AIM Higher is a consortium related to supply chain. I'm sure that many of you appreciate the value of a great supply chain, which can combine multiple components from multiple vendors to assemble them into product. Then building construction industry has a similar challenge, and people try to produce different components of building and assemble them into our product called building. And the modular construction in our industry has shown some potential to reduce the schedule and the budget. As you can see from these two pictures I show on the screen, more than 90 or around 90% of the general contractors from the construction industry, they perceive a significant reduction of the schedule and cost of producing buildings. So that's a big thing for building construction industry, considering how many dollars we put into building those houses and facilities. Another one is the EPA. They have the report showing that modular construction has the strong potential to reduce the waste. And reducing the waste is also has a big impact for us to make a sustainable community and a sustainable future. I discussed with the industry partner about their practical problem, and I learned a lot from them, just like what I'm trying to learn from all of you here today. From here, we can see that DMI company, they are manufacturing HVAC system, which means mechanical system component of buildings, such as ducts, pump. I would say mainly are duct works for delivering water, air to buildings. Then their production process is actually a little bit more automated compared with the traditional construction industry. They have a manufacturing execution system, just like what I show on the bottom right. It's a software allow us to visualize the productivity and all kinds of events that influence the productivity and the cost of the production process. However, they find out that in many cases, even a very, very automated control system could not behave like a human operator. Sometimes they are asking for help from experienced operator, For example, whenever I see something happens, like a recover from the machinery fault, and people is going to say, okay, let's ask for John, let's ask Larry, and I am just asking, why Larry, why John? Because they know it, and what they know, and what they say is that they know a lot of those things, which is not just productivity, not just about the cost. They're also talking about the balance between multiple criteria, especially when the production process has switches. So what they mean by switch is that for the same production line, they are hoping to deal with the changing demand from the market. They want to make sure that it's a more flexible for them to produce different products using the same manufacturing line, but that switch between different products could be tricky, and only experienced human can finish that kind of a switch with all kinds of criteria in mind, such as safety, machine force, productivity, and the maintenance cost of the machines. Another one is from a less automated building construction process. They call modular house. This is like a factory from Pennsylvania. I believe it's in the middle of Pennsylvania, not very far from Pittsburgh. They are producing modular rooms, which has a water system, electronic system already completed. And all they need to do is that to haul those modular rooms away through trucks and assemble those rooms into buildings on site, into like a 5-bedroom, 4-bedroom, single family houses on site. Then, so this kind of process, there is a very, very limited automation, but the advantage is that in a controlled environment, they allow the workers to have much better working environment, assemble those prefabricated components into rooms, and the quality of those rooms seems to be better. However, they also have a human-centric approach. They feel like sometimes they also need some production flexibility. Say, I want to produce this type of room versus that type of room to satisfy the changing demand of the market. And if they want to do that kind of switch, they need a human manager to coordinate a lot of things. Those coordination could be coordination across multiple workers, and they also need to rearrange the workspace for producing different modules of like different rooms. Then for that kind of coordination, it's a very, very important for the project manager. In this case, it's the person who managing this factory. They balance multiple criteria, similar as what we had in the last example. Those criteria is slightly different, and maybe it's even more complicated, such as safety, productivity, and even trickier is the design construction coordination. People design, but not necessarily fully consider everything, every unexpected things happen, like there is a new discovery, and there is difficulties of putting a machine inside a small space to finish an installation. They need to have the communication between design and construction to make sure that they still produce similar thing and without losing their productivity. So that flexibility issue across the semi-automated production of a building mechanical system component and the modular house motivate us to think about what human really know more than a computer. They ask for Larry's help, John's help, project manager's help, the coordination of the design engineers. What happened during those process, and how those multiple experienced, very smart engineers communicate with each other and solve those issues for flexible switch between different production mode. Then, so that comes with our idea of a production digital twin. That means we want to capture the history of a production, including the communication between the worker and how they move across the factory assembly line, and what happened in the manufacturing execution system when people push a button to solve a problem, to switch, and to make sure that they adjust those parameters of a production line in a way that fully consider multiple criteria. Then that's what happened. Then the next thing is like, once we know what happened, what human do, and could computer learn from human to become a better manager? Computer becomes smarter and learn from those historical control process to be able to do adaptive process control. Then in that case, we have the computer observing what human do in different scenario, and we allow computer to learn from those scenarios and to understand how to control a process which has production mode change and some unexpected situation on the site. How computer learn from human, it's interesting, but it's not that straightforward. There is a bunch of questions, there is a bunch of challenges. We formulate a few questions based on our experiences with a similar situation we meet in our past study. And I'm going to introduce our research related to these 4 questions on the screen. Number 1, can computer summarize what skillful workers is doing in different situations? Can computer find out what are the similar strategy the worker use to solve certain situation? Can computer explain what are the critical things they need to do as a human always know what to control and what to do better? Could computer do even better than human to do that's optimization? Look at what people has been done and try to explore, is there any even better strategy? Then for this 4, we have 4 corresponding research tasks we just started this year, precisely last month. We start to think about how to apply and adapting, extending our existing work to answer those 4 questions. For the first question, it's could we capturing what really happens in the history? That means we capture what's the history and recover the events and the task information from multiple type of data. So those data could be sensor data, data from the sensors installed on the manufacturing line, videos, field notes. Let's take a look at this first one. So the video data, we have done some work for nuclear power plant control, and that's a work schedule control problem. We look at the radiation protection island of a nuclear power plant a reactor. Before people get into a reactor, they need to go through the room to check the radiation dose of them and to make sure that they are not going to have extra dose exposure to cause their health problem. But that check-in process is corresponding to a schedule because people need to get in and they need to check in. And if a room got too many tasks happening at the same time, a lot of people will get in and spend a lot of time to check in, and maybe that's going to cause troubles for those people who are doing the work, relying on their work to be able to get into the reactor to do their work. Look at this, we automatically use the video camera installed in this room and to see how much time people spend on these check-in stations. And it's pretty much like the Walmart, and people form into lines when they are busier, and if a person stay there too long, it becomes red, and the yellow means it's going to be causing a problem and before become red. Then taking those information, recover those schedule information, we put into a simulation of a construction schedule, and we will be able to predict what's the impact of a delay of one person's work, and how they spend too much time in this room is going to cause trouble down the line. Then we also have this spatial domain problem we studied for airport, for construction site, for assembly room, and for even for supply chain, like a transportation network. We understand that we want to really understand what is the congestion happen, where the delay happens. What we did here is that for Los Angeles airport, we got the 1,700 flights in 24 hours, and to understand what are the most frequently used route in the busy time or not so busy time of the airport, and which part of those air traffic control process causing the delay of a flight. Then, so the interesting part here is that we don't have the flight schedule of Los Angeles airport. We only look at the GPS signal. I think that should not be said GPS. It's a similar GPS, but it's a navigation system used by aircraft to continuously tracking the position of aircraft and to see how many aircraft go through the taxi line, runway to the gate, and which section of the runway and the taxiway has what type of a speed, and what is the distribution, average, and the variation of those speed to be able to support where has those congestion happened, and what are the bottleneck of the airport operation. And what we did was we do some clustering, and even without knowing what are the standard route used by the airport, because the airport, the air traffic controller, they always have the knowledge saying, I should use route 1, route 2, which is predefined by the airport operation manual, and we automatically recognize those route frequently used by airport air traffic controllers in practice. Only use the navigation data. For example, look at the bottom. So this is the automatically recognized 31 aircraft use this route landing here and go to the gate. And another one, 3 aircraft landing from the north and go to the gate, which is on the south. From here, we can see that we can do process project reconstruction, because using video, we see how people moving in a room and at what time. And using the GPS and navigation data, we can reconstruct the operation of a transportation network and analyzing the trajectory and understand the efficiency and the delays. Then the next question is, could we find out what are the similar things happening, and people can use a similar strategy to deal with a similar problem. What we developed is called process mining algorithm, which look at the many control history of civil infrastructure. In this case, it's a nuclear power plant, and a nuclear power plant has a control room, and the human who work on those type of coordination of the operation of a control room of a nuclear facility is, number one, they check the sensor readings on a very big control panel in a room, and they send out the field worker to the site and guiding them to fix the issues, or the taking some observation which cannot be measured by sensor, and to help them to solve some issues which cannot be automatically solved remotely. Now, from here, we look at the log sensor readings of those control room, and to find out what our experienced operator of a nuclear facility is doing when they are handling different tasks to fix the issues during the operation of a nuclear facility. So the challenge is that we want the worker to have the real-time situation awareness to understand this is the real-time state of the nuclear facility, and there is a few options we should try to make sure that the operation of the nuclear facility is safe and is also going to be efficient. So what kind of data we have? So the data, well, I simplify the data. There are many more, and I just give you some example, such as the temperature sensor reading and the valve data. And we call the valve data on and off switch. And the analog parameter is the sensor reading. And we automatically extracting when certain things happening, when certain temperature change or cooling flow change trigger people to switch on and off the valves. And we actually have the computer learn from those processes to predict in what kind of a situation measured by the sensor, the multiple sensors readings, and when people see those sensor readings and what they should do, and to predict what experienced person is doing. The prediction, I would not go too much detail into this. The prediction right now, it's actually a pretty simple model using the clustering. What I mean by clustering is like to group similar sensor readings and corresponding to control actions to predict in this similar situation, people is going to do this. The interesting observation from top down is that we can see that when the process starts, the prediction is pretty accurate, but when things going on and on, the prediction accuracy kind of drop. And we are trying to improve the algorithm to make sure that in the future, the computer kind of summarize similar situation, people do this and can predict what the experienced person is going to do, and to help, and the computer can suggest control actions based on the contextual sensor readings. Then, so that part is actually the learning process. We want to see how the learning and the process pattern repeated in manufacturing lines of building manufacturing systems like HVAC system production and the modular housing system to help us to understand what people do in similar situations to deal with switches and to recover from an abnormal situation. Then sometimes we know similar times people doing similar things, but it's even more helpful to explain why they do this. Then so that's another work we call like a failure mode correlation analysis. Say this is the failure mode, and to see what kind of failure mode is related to what parameter of the manufacturing line. Then so what we study here is the failure mode is the congestion of an airport. It's the airport I just mentioned before. We look at the real world hotspot in Los Angeles airport and to see which part of the airport tends to have more congestions. Then we also use the historical data to build a simulation model. So that simulation model use the random numbers produced from historical data. Those random numbers can be average speed, variance of the speed along several sections of the transportation network, such as taxiway, runway, and nearby the gate, to simulate the landing and the departure process and to predict which, if we have a flight schedule, what are the likelihood to have certain areas have more congestions, and we call collision hotspot. Then, so that's a very powerful tool. We can see that this is the real world congestion we observed from the historical data. That's 1 day, 24 hours of data. And the north part of this runway have a lot of congestions. The aircraft are moving pretty slow. And the south part has a lot of gate, has those congestions. And we use the historical data for that same day and produce a simulation model. And so this simulation actually kind of align pretty well with that historical records. We slightly switch the flight schedule, make it busier and busier, and which means we got more aircraft landing and departure, and we can predict which area are going to have a growing number of congestion and causing more flight delays. So that one is kind of like we look at those intersection and cross sections of the airport transportation network, and to explain which aircraft, which intersection is the bottleneck, and how we should resolve those issues with those intersections, and how to pinpoint some of those aircraft which are troublemaker to resolve a lot of those delays. Then simulation is a powerful tool without getting to a real world to understand, okay, this is the bad control strategy, which is going to cause even more delays. And we just play some of those control strategy with a simulation system based on real historical data to explain these are the critical points, and we should adjust this intersection, or we should pay more attention to this aircraft. So that explanation could help us to explain the manufacturing process and to pinpoint the critical manufacturing parameter, and to help people to pay more attention to certain steps and to improve the safety and the productivity. Finally, can computer do even better? Actually, this is the simulation I just mentioned for the airport. And we use those simulation of air traffic on the ground nearby Los Angeles airport. And so that simulation help us to predict the congestion scenario. And we finished that prediction. That's not enough. On the left side is the prediction. On the right side, it's going to be reinforcement learning algorithm, which is ongoing work supported by Airport Cooperative Research Program, and to see is there any possibility for computer automatically recommend a control strategy, for example, automatically remind the air traffic controller to pay more attention to a particular section. Is there any even better strategy adopted before, not adopted before, and could be better than what the air traffic controller, even the best air traffic controller has done? It's pretty similar as we learn from the game, the best game player, and the computer become an even better player than the best player in the world. So that's what we call optimizing reconfiguration strategy, because we understand that as AIM2Learn consortium has been emphasized, reconfiguration it's a change, but we should embracing those change. We should handling those supply chain challenges, and because we have those change in demand from the market, and we want make our manufacturing line more flexible and smart, and to switch between different modes to be able to produce more product with more efficiency and less safety or maintenance concerns. Then this is the recap of everything I just mentioned. It's the whole project. We want to recover what happened from all kinds of data. And we have just started this project with 2 industry partners. And based on our algorithm developed from the airport operation, nuclear power plant operation, and to see could those algorithms help us to discover what is the production process in the building manufacturing lines, and could computer automatically and safely handling some of those abnormal situations which happening during the transition process of a manufacturing line, or the machine has small problems, and just like an experienced human know how to deal with those situations, the computer suggests what is the solution. So with that being said, thank you very much, and I hope that's not too long for this presentation. Thank you.
Thank you, Dr. Tang. You ended just about perfectly on time, so I appreciate that. There's a lot of great information. I did make a note in chat. I forgot to mention that at the beginning, that if anyone had any questions, they could put those in the chat. I didn't see anything at this point, but I did want to remind everyone that we are recording this presentation, and we will have a copy of it on the AIM Hire Consortium website. Probably in about a week it'll be available. So if you want to go back and review this, or if you want to share it with a colleague who wasn't able to participate or listen in, that will be available for everyone. So again, thank you, Dr. Tang. Thank you everyone for attending, and hopefully you'll be able to join us for future informational sessions like this. And again, thank you all for your time.
Thank you very much, Tom, for inviting me, and it's my honor to get associated with AIM Hire.
Yes, that was fantastic. Great. Thank you very much.
Thank you.